Hey guys, I'm MikroTik Marc, and welcome to Bridge Mode, where we connect with real-world network operators and professionals to talk about network deployments and explore their questions and stories. Join us as we connect ideas, solutions, and the people who make it all happen. Today we've got Jonathan Sellers and Jonathan Robin with Alpha Omega Broadband, and we're just going to jam out here, talk a little bit about some pop configs at an edge router that's got a DAA circuit, and take a look at some of the configurations here and talk through, why are some of the configuration items configured the way they are, and maybe learn something. So Jonathan, where do you want to start?
I'm going to pull up an edge router that we have, and here we are at a blank slate, and IP with the addressing and the firewalling and the layer 3 items. That's where I think is a great place to begin.
All right, so do you have questions in particular, or do you just want to start diving in and looking at some stuff and going, hey, what is...
Right here under the firewall is where my big question marks are. We've got the firewall tab open with all the filter rules, NAT, Mangle, and the rest of those tabs. So we've got some stuff going on here. I've never learned firewalling, so I don't even know what I'm looking at. Right? To me, it looks like stop signs and go signs for
Yeah, so
traffic.
let me start with a couple of suggestions here, and then so first off, I've done a firewall best practices video. There's two parts to it. They're available on YouTube. You can check them from our website or our YouTube channel. I highly suggest checking those out. But in addition, right here, right on the bat, I see on the left-hand side, you've got things sorted by out interface list right now. There's some arrows in interface list. If you look at those two columns, you'll see some arrows there at the top of this list. And so those out interface list and in interface list are weird things to sort by. So I would sort first by the number by hitting the pound button on the top left. And firewall filter, all the firewall facilities here get processed in the order that they're seen on the screen by number. So they'll get rule number 1, rule number 2, rule number 3. When they match on a rule, they will no longer continue processing unless there's what's called the pass-through, which means keep going through the next firewall rule until you find the next match. Sometimes you do that for counter reasons, just to see whether something matches, but you still want it to keep going and see if it matches something else as well. Just like you said, you've got green lights, red lights. So we do have a bunch of green except rules. So on a Cisco, for example, the typical firewall behavior is that traffic is blocked unless you allow it. On a MikroTik, if you come in and there's no firewall rules at all, the typical behavior is the opposite. It says allow everything unless I say not to. So very common on MikroTik to kind of start off with a strategy of put in stuff that you want to allow, and then at the end, drop everything else that you haven't specifically allowed. But some people miss that step, and their routers are actually exposed in ways that they're not aware of by not having a default drop rule. So that's one thing to know right off the bat. So next up, what would be useful to see here is that you've got your green light, red light. There are conditions that we're going to talk about and triggering behaviors, but what's important to know is that if you look on the chain here, which is like the third column, there's input, there's output, and there's forward. So if you're not familiar with what those mean, input means traffic that is destined for this router. Output traffic is traffic that started at this router. And forward traffic is traffic that is not started or destined for this router. It's stuff that's just passing through. And that's the typical routing protocol. So that's going to be your customer traffic for you as an ISP. This is going to be all of your customer traffic is neither destined for this router nor originating from this router. They're originating out from the internet, passing through this router, and going to your customer, or vice versa. So that being said, maybe we'll jump into some of these triggers. and talk through some of the information that you're seeing here on the screen. So I can see some allowed remote Winbox, what those are doing, rules number 0 and 1, and a couple of other ones there. It looks like what we're saying is we want to allow some what's now Admiral Platform traffic. And that in particular, rule number 1 on the input rule is saying that for traffic that comes in on our VPN tunnel for our management interface, you're going to allow that traffic. I'm not quite sure what the forward rules are there for, but that could be that you've got a block rule later on that blocks some forward traffic that's maybe specific to some private IPs, RFC 1918 IPs. You can look on the right-hand side, and something that I look at pretty quickly is this rule actually doing anything? And if you got 0 counters over there, which you do, that means that this rule hasn't triggered since the last time it was rebooted or the last time you reset counters. So you can see right at the top of the list there's a reset counters and reset all counters buttons. Those can be useful for when you're troubleshooting and you just made a change and you're like, okay, now does my rule apply, or am I getting new packets for this kind of traffic that I'm trying to match on?
Gotcha, yeah.
So right now, those 2 rules aren't doing anything as far as we can tell. And then next up, and yeah, any questions here you want to talk about?
Yeah, real quick, we did a migration from the remote Winbox platform to the Admiral platform, and I believe that these rules were in place for that migration and are just legacy rules.
Gotcha. So in that case, one thing that I like to do if I'm not quite sure, maybe I get access to a new network as a consultant. One of the things I'll do here is disable this rule, leave it disabled for a week, a month, and then if I see that there's been no complaints on a disabled rule, we know that they're clear to be removed. In this case, happening to know that we did this migration and understanding that what this was for, it's safe that you could just hit the minus on these and delete these.
Okay, that's the number 2 and the number 3 item.
You got it. Yep.
Okay.
One other thing I like to do when I'm doing firewall manipulations is to turn on safe mode. So at the top there, you've got a safe mode button. If you turn on safe mode, then if we make a mistake and you lose access, what'll happen is it'll undo any changes that you've taken during safe mode. The only thing to consider is that when you start using safe mode, don't forget to disable it when your work is done. There was one time I jumped in on an emergency maintenance activity, and we turned safe mode on right away so that we wouldn't lose remote access. Made a bunch of changes. We fixed the network, and then we forgot to unlodge safe mode before we terminated for the night, and then ended up undoing all of the fixes that we did. So you got to be aware that safe mode is there when you use it. But it does allow for, what happens is that behind the scenes, the MikroTik starts tracking the session to your Winbox here. And so if it finds out that your Winbox communication terminates, then it just says, hey, from the time that safe mode was taken until now, I need to roll back all those changes. All right, so looking at some of these other firewall rules, you can see that you're running some WireGuard. I would imagine, I hope that you know what that's for, and it looks like you're doing that for VPN access.
Yeah, that's you can see later on here, there's some people that use a different VPN than Admiral, which existed before Admiral was put on. So yeah, these are also remain in place for VPN access.
Yeah, that's what it looks like to me, is that, and you've got some good comments here. I like having good comments on all my rules. So it looks like, several of these next rule 3, 4, 5, 6, 7, 8, 9 are all, just allowing some traffic to terminate on this MikroTik.
Okay, yeah, that's what you said earlier. Input means it lands on this router.
Exactly, exactly.
Okay,
So then it looks like rule 11 here is where we start to see, there's no comments here. So now we got to start wondering, okay, what does this mean? What you can see is that it's an accept on input, and you can see a protocol of IPsec. So rather than being TCP or UDP, this is going to be trying to establish a tunnel connection to this MikroTik, probably an encrypted tunnel or a GRE tunnel. Not sure what that used to be used for, but you can see 0 packet counters on there. This is another scenario where I would, if this router's been up for a while and you got 0 packet counters, I'd probably disable that rule if you're new to the network and come back in a week or a month and see if nobody's complained. Probably safe to remove.
okay.
Yeah, I guess to give some background on that, we previously had an IPsec site-to-site tunnel between two of the POPs. And the rules are scoped specifically only to the IP addresses.
And I brought those two up, Jonathan, right there. I don't know if you can see the screen also from your perspective, but they're just disabled right now. That's all.
Yeah,
Right.
so if you plan on bringing those back and using them as, emergency access, or maybe we'll use those later, I would just add comments here to say,
Do not remove.
temp VPNs don't remove or something like that.
Okay. Okay.
So another way to sort rules can be to sort them by chain instead of by number, because they do get processed not only top to bottom in order, but also input rules all get processed together, forward rules get processed together, output rules get processed together. So me personally, when I make my firewall rules, I'll put them physically all together. So you'll notice that if you click on a rule, you can drag it up and down, and that'll reorder the location of processing of that firewall rule. I personally keep all of my input rules at the top, and then I do forward rules, and then I do output rules, just because that's the way they actually get processed. But in your case, you'll see here that down there at rule 19 is a forward rule, even though it's, or 20 is the forward rule. So even though it's there at 20, rule for an input packet, it actually goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 19, and then it skips ahead to 22, even though 19 and 20, or 20 and 21 are there. They're forward rules, so they don't apply to that packet. So just for ease of human readability, I will sometimes bundle them together so that they're more visibly understood on how they process. But functionally, it doesn't, the router doesn't care.
Okay.
So moving on to a couple more rules here that we can see. At 10, 11, 12, 13, those all look like they're related to that site-to-site VPN. Then you had a couple of disabled rules. And then it looks like you've got an accept that's also on a different tunnel type for rule 17, the IP-IP tunnel. And then you've got a drop on, so it looks to me like there might be redundant rules. You got 17 and 19. 17 says accept everything on that knock tunnel, and then 19 says drop everything. So in that case, 19 would never trigger unless it happens that there's extra conditions that occur inside that firewall rule. So one thing to know is that we're looking at kind of the overview screen here, and you can turn on or off a whole bunch of different columns. So if you right click right now and then go to show columns, you'll see that there's a whole bunch of columns available and only some of them are turned on. So that's what I mean by additional matching criteria, is that some of these other things might be turned on. You're just not seeing them as part of this configuration. So go ahead and cancel here. Let's go into the rule 17 and see if there's additional criteria or if this would never happen. All right, so we've got an input rule on a IP-IP tunnel. There's no other matching criteria here, so let's do advanced. Nothing selected here. Let's do extra. Nothing selected here. So what I can say for sure then is that rule 17 would say all traffic that comes from that tunnel is allowed. Rule 19 would never trigger because rule 17 already allowed everything. So this is a good case that shows where, firewall rules would need to be tuned. I'm not sure what you're trying to accomplish with this rule, and maybe it's so far back that you don't remember either. In which
Yeah,
case, both of these could be disabled and maybe removed.
Yeah, this is kind of leftover stuff from an older setup. I think I might have put the drop rule there just so that I could see if there was traffic going when I killed the accept rule versus it going to the catch-all deny rule. But I don't
Gotcha.
know.
Yeah,
It's
so
been
just
years.
troubleshooting. Yep.
Yeah, and also this original configuration was on an 1100 AX-H4 Dude Edition router, and this is we're on an RB 5009 instead now. So there's just some of those issues to go along with whatever else you see.
Gotcha.
As
So the
far as
next,
firewall rules go, they should be exactly the same as they were on both units.
yeah, and it's probably not hurting anything other than being visually difficult to it's taking extra energy to look at this and go, does this mean anything? But you can see the 0 packet counters there. So performance wise, it's not really affecting the router much, consuming a slight amount of memory and some CPU resource as traffic goes further down the firewall. But that's minuscule compared to what it could be. So personally, I would clean it up, but it also isn't hurting anything. Next two rules are IPsec related. When you have an IPsec policy on here, these get automatically generated by MikroTik configuration. So next up, you've got allow ICMP. One thing that you can do, and there's plenty of articles online to take a look at this. If you double click on that, and let's take a look here. So look under advanced and extra. All right, so what we're doing with this rule is allowing all ICMP. And if you take a look into what ICMP can do, it's a protocol that is very more robust than many people give it credit for. There are certain types of ICMP packets that often get used for abuse. So many folks, to enhance their ICMP firewall, will allow only the types that are more or less safe to use, and they'll deny the other types. You'd have to look at the RFC. There's dozens of types, and so I don't know. There's half a dozen that are safe to use. Again, you can look up online for a good MikroTik ICMP policy, and then it'll show you which types are the right ones to allow. And what people typically do is they'll build a rule here, and if you double click on this, the action right now is to allow. What they'll typically do is say action is to jump to a new firewall rule. And then you can, if you click jump, it'll show you here, you can pick a jump target, and then you pick ICMP chain or something like along those lines. And then in the ICMP chain, you'll define, hey, here's the 6 types of ICMP packets that I want to allow. And then if it's not one of those 6 types, it's one of the rest of the bad guys, I'm going to deny it.
Okay, so right now the jump target ICMP isn't showing up, but that's only because we didn't put ICMP in somewhere else.
Yeah, so let's go ahead and do under action here. You can just type it in, and then it'll become part of your known configuration.
Oh, okay, so it does not have to be part of the dropdown. That's good. And I hit
Yep.
apply. I might have should have waited.
Yep. So now what you'll want to do is build a new firewall rule that accepts that ICMP. So right now it's jumping to a chain that doesn't have any rules on it. And so if you hit a plus now, and now our chain is going to become ICMP instead of input. So now the only way to get to this is by being on an input ICMP type. And so now we can say, and I guess I'll pull up quickly some background info. For example, if you just want to allow echo request and echo reply, which are the typical thing that you send a ping and you get a reply. You would go on your new rule. Is this a new rule? Is this
Yeah,
the,
it's the firewall rule, allow ICMP the jump rule, action jump.
yeah, so where'd the, did we make a new rule? If you click on Windows on the left,
Where'd that go?
all the way at the bottom,
Yeah,
there it is. New firewall rule. That's the one. I think we just, there it is. All right, so chain ICMP. If you go to advanced, can't remember if it's under advanced or extra. Try extra. Nope, it's under advanced. Look at IPv4 options. Nope. Nope. Up arrow on that guy. This is one of the things I don't do on the Winbox very often. So we're looking for ICMP options.
Yeah, that may only be something available from the CLI.
do you want me to go to open up a
Nope,
terminal?
it's right there. I see it. So what we have to do back on the general tab
Oh, there.
is select protocol ICMP. And then on the advanced tab, it'll allow us to select the ICMP options. Nope, not IPv4, ICMP. Next one up. There you go. And now, yep, so we got echo reply. You can hit apply on this guy and then copy him. Yep. And then again, click on advanced, change the echo reply to echo request. And then you can see there that it lists all of the different types. And so you should allow destination unreachables, host unreachables, port unreachables, fragmentation messages. There's a handful of other ones that we could allow, but if you wanted to get real tight on this, you could just allow echo request, echo replies, destination unreachable, source host unreachable, and then maybe time exceeded probably is a good one to have. Redirects are there for, you know, routers to tell other routers that there's new gateways available that are a better path. In our case, I'm pointing out that we can build a jump chain. We could, and I'll send you guys, I suppose as part of this video, I will do a shout out to one of my MikroTik trainers, Rick Frey. He has provided on his website a nice basic firewall that has a whole bunch of options in it for tons of different things. And one of those things is a good firewall to protect your ICMP, but also allow some of the important messages to get through.
Yeah, that'll be great for this menu here for sure.
Yeah, so I'm going to drop that in the chat here, and then I'll put it in the comments on the video.
We're ready for it to hit apply on this screen.
Yep.
Okay, done.
And so now what you should see is that you're probably getting some counters on those. And so you'll scroll all the way to the bottom where it's putting the new firewall rules. And you'll see two rules that are ICMP chain instead. And yeah, you can see there you're getting some packets through. Now you probably want to add some of those other there's other types, and I don't want to burn all of our time just looking at ICMP only. So I'd rather kind of look at some of these other rules and see what else we can tell here.
Okay. Yeah, I'm back up here at where we were.
All right. So we now have an ICMP rule. You may be dropping some ICMPs now that are not matching on. So what happens now with this rule is that when it's ICMP, it jumps to the ICMP rule, the chain. it used to say, I accept all ICMP packets, doesn't matter which ones they are. Now you're only allowing the ones that are echo request and echo replies. So you may be dropping some other types of traffic that are ICMP related, and may be legitimate, and you may want those in there. So again, look at that Rick Frey firewall and decide if there's any additional ones you want to add to your list there. But you saw how you do it. You just add another rule, pick ICMP as the chain, and you can allow other types of ICMP messages.
Back here on the general, there was nothing else, just ICMP. Here on advanced, it is down here on IPv4 options and
ICMP
excuse
options.
me, my bad, yeah. But that's not enabled at this point because we haven't added the new rule. Is that why, or
No, because that
protocol has it?
particular option is only available if you select the ICMP type of protocol.
So we have
now
to add the protocol here.
You got it. So now that you've said, and you don't have to apply here, you can just go over there. It knows that when ICMP is the type of packet, that it says, okay, this is all right then.
So without having to go through this whole list, but to allow valid ICMP traffic is something that you have to follow up with your jump rule so that you're allowing legitimate ICMP traffic to pass.
Yeah, and now, so what I would personally do here is, since we're adding a third rule here, so what'll happen is that if it's ICMP, it comes into the top of the firewall rule, looks at chain input, goes, hey, I'm an ICMP packet that's input, so I need to jump to the ICMP chain. It'll process whether it's an echo request or echo reply. And then if it's not right now, it'll drop down to the next rule, rule number 23, and keep going down the list because it hasn't found a match yet. So if I know that I only care about echo requests and echo replies for ICMP, my next rule would be ICMP drop.
But then we also want to know, in this case, it's an OSPF routed network with multiple hops involved. So the redirect is also important for the OSPF.
Yep. So you can certainly add redirect, and you could add several others as well. Yep.
Okay. And once I add this new rule, I don't have there's not another rule that I have to add to counter this rule, is there?
So what I'm saying is that if you wanted to drop every other type of traffic besides requests, replies, and redirects, then you would add one more rule to drop, because again, MikroTik doesn't have a default drop.
Okay.
Now there might be a default drop later on in your firewall filtering that we haven't looked at yet, so that may not be necessary unless you wanted to short circuit it when it's an ICMP packet.
Okay. So yeah, we're not there yet. We've got to keep looking, like what you.
Now, one other thing I would say to do real quick is scroll back down to the bottom, grab those guys and put a comment on them. So, you know, again, if you're looking at the summary screen, it just says accept ICMP. And in our case, we know that this one is accept echo reply.
So essentially, you're just taking the details off of the advanced screen and making a comment so you have some relevance.
Exactly. So that I don't have to dive in deeper to see which rule means what.
And then
I would do the same thing with the other one and say accept echo request. And if you want a shortcut to how you get to a comment, it's just at the top of the screen, there's the plus, the minus, the check, the X for add, remove, enable, disable, and then the little yellow sticky note there is the comment button.
Gotcha. Okay, so you highlight your field and then you hit the yellow sticky to do a comment.
Yep.
All right.
All right, so let's go back to 23, I think is where we were. And we'll take a look at some of these other rules.
Here we are.
All right, so when it's red, it means that it's not able to apply this filter because of something in the configuration. The rule is inactive. And you can see at the bottom there, it says management VLAN 100 is not ready. And so
Okay.
at this point, I'm guessing management VLAN 100 is disabled. Administratively, configuration wise, it's probably disabled. Either that or it's assigned to an
Right.
interface that's currently down. And we could check that. So if you go to interfaces, we can find out why this guy is red. Management VLAN 100 is on, but if you double click it, what interface is assigned to? It's on bridge 1. Okay, so now let's look at bridge 1. Bridge 1 is disabled.
Okay, so there's a why. That's why the firewall is red.
You got it. Yep.
Okay. And for some background, we've got when we made that switch from the 1100 to the RB 5009, we just put that switch that sits behind the router onto just a plain old routed network instead of a VLAN.
Okay. So yeah, I guess up to you whether you want to keep any of this legacy stuff around or whether it's time to clean that up.
Okay, it's basically I just didn't want to remove things without knowing what was going on.
Absolutely. Yep. And that's a good place to start.
Okay.
All right. So next couple of rules, we've got some in-interface lists. So one of the things that's cool about a MikroTik is that you can use lists to define what rules, a trigger criteria to apply. And those can be interface lists or address lists. In interface lists, they live in interface and then interface list. In address lists, they live inside a firewall. And what this allows you to do is apply multiple. You can have one firewall rule that can apply to multiple interfaces or multiple IP subnets.
This is how you take your firewall rule and apply it almost like a role or a user type management system where the list over here says who's using it.
Yeah, so I can tell that the strategy that whoever built this firewall is definitely different than the kind of strategy that I use. And I'll give background on this. Before implementing a trust my known network strategy and then block everything else, I came upon a router that was doing kind of like this. Hey, I'm going to define bad guys and I'm going to block bad guys. And I'm also going to give people the opportunity to try to talk to my MikroTik. And then if they try and talk to it a whole bunch of times unsuccessfully, I'm going to also mark them as bad guys. And what that does is that consumes resources by tracking all of the bad guys. And it also allows bad guys the opportunity to try to connect. And when you use that strategy, one of the MikroTiks that I ran into was using 60% average CPU. When I implemented a new firewall strategy that said, allow trusted only, drop everything else, it took the firewall rule, the filter rules down from a couple hundred to a couple dozen. And on the address lists, the bad guy list got to be hundreds of thousands of items long. And that takes that down. Your address lists become, I trust this dozen locations and everything else is not trusted. And so your address list goes from 100,000 or a couple 100,000 to nothing, just a couple dozen. So resource-wise, it's very, very nice. And we went from 60% peak, 60% average CPU to, in the teens of average CPU.
That's a huge decrease in CPU usage. So with having say a dozen or more rules versus hundreds of rules, by having a different strategy, then at that point, are you able to the only thing that's keeping the bad guys out is that they're not trusted in the first place.
You got it. Yeah. So they don't have any awareness that it's here.
And those 12 or so rules, let's say it's give or take some, whatever it turns out to be, then you're allowing things in from places like your monitoring service, your billing software, any kind of bandwidth shaping, any other cloud services that are relevant to network management, and those are considered your trusted sources.
Exactly. So pretty common on networks that I work on to say, hey, RFC 1918, those private 10 networks, 172, 192, sometimes CGNAT. You'll say, hey, I want to allow traffic to hit the input chain on this. You can really narrow it down and do very specific /32s or /24s or whatever in between there if you want to really get isolated down really well. But I like to take a layered approach. And so I'll have, kind of a looser address list that's allowed for maybe the 10 dot anything. And I use a whole bunch of 10 IPs to build my management network. And then that way I can get in from, anywhere else on my management network. But then I also will have, randomized credentials for getting into that account. I'll maybe change the default ports that are used so that you're not getting in on SSH or Winbox on the standard port, just so that there's a little extra difficulty for anybody who's trying to abuse my system to get in. But as long as you're only allowing private IPs, right, that means that it's not going to be able to hit a BGP routing edge that's configured properly. That's going to, or your DIA should not allow traffic. It should filter all traffic that's not public internet traffic. So it's usually pretty safe to say, hey, I'm going to allow some RFC 1918 address space to talk to this guy. But you can, take a looser or tighter approach depending on what your security policy looks like.
Okay. So, do you want me to just get out of the address list tab then?
Yeah, we can go back. We were looking at the interface lists and trying to understand what this allow VLAN guy was trying to do. I see there's only one. So it's that management VLAN again with that management bridge that's currently disabled. So that's why it's got 0 packet counters on it. And in a similar way, I think that guy's probably legacy.
Yeah, there was and before Jonathan, Robin was came in and helped out tremendously. I had another great resource in the Philippines. Our schedule, 12 hours time difference, was just wound up being too much. But yeah, he began to do stuff that Jonathan had to follow. So it's nothing here is any one person's work.
Mm.
Yeah,
Gotcha.
and I think also just to prevent any or like make things easily reversible or just not create any problems. A lot of things were just disabled or just left as is if everything was working.
Yeah, that's a common strategy, right? You don't want to remove anything that might break
Yeah.
operations, right? So yeah, that's why I say I'll take the strategy. And as I disable things, you might leave a comment, right? Like, I think this is unused, or remove in August if it's still here.
Anyway, where I'm at was you have MikroTik comes with default LAN and WAN. And if you're going to do anything customized, you're going to hit add, excuse me, you're going to add a list over here, and then you add it over here, and then it shows up on the main screen, of course, once you're done. But is there anything beyond just for a human being to catalog and keep track of things? I didn't really understand anything going on. I just decided, well, I want to use external and internal, because I thought, well, subscriber subnets on a point to multi-point wireless platform that's like internal to that subnet, and that's just how I looked at it. So I'm going to name this interface list an internal one because it's pointing to people on a private net on a 10.xxx network. And then they each all get their own DHCP, and they have their NAT for their home CPE, and it works, right? But what I don't understand about here is, how does the list name tie into other places in the Winbox environment, in the Router OS world?
Yeah, so that's where I was getting at on the firewall filter side, and maybe a little more interesting if you're going to do something like hey, these interfaces over here face some maybe older radios that don't have a high MTU capability. So when I send traffic over there, I got to do something like clamp to physical MTU, or I want to adjust the maximum sequence size or something interesting like that. And maybe I've got 5 interfaces like that. You could do something with 5 mangle rules, or if you used an interface list like this, then you could say, hey, I define these as old radios is maybe the interface list name, and I've got a couple of physical interfaces that are tied to that list. Then I can make one firewall mangle rule, and it's a little easier to read in the configuration. So it's really not about functionality wise that it's really any different to build the 5 firewall rules versus one firewall rule. It's all about, again, being able to understand that this gives me an easier readability for humans to go, oh, okay, this rule means, change the sequence size. And I'm doing that over here for anything that is called old radio. And then I can look over here in the interface list to see which physical interfaces are tied to those old radios. So it's just a different way to think about it. Functionally, it would behave the same having 5 rules versus having 5 interface lists.
Okay, so I can use interface list over here or mangle over here to achieve the same outcome.
Yeah, and so I'm giving a pretty simple example of just maybe I need to modify the sequence size, max sequence size. But let's say I needed to do 5 or 6 things, or even 20 or 30 things. Well, now again, if I've got 5 old radios, I have to do 5 rules for each of the 5 radios, right? And so if I have maybe I need to change the sequence size, and I need to change the MTU, and I need to mark these connections, right? And because I'm going to do some quality of service stuff, and maybe each quality of service stuff because I'm doing voice over IP and video, and I want to do some of that ICMP stuff differently on those guys because they have a special case scenario. You can see pretty quickly every configuration directive gets multiplied by 5. So if I have a interface list or an address list, now I can do one mangle rule per thing that I want to do instead of times 5.
Okay, so which strategy would you say is a best practices for your average ISP with a DIA circuit and some OSPF, maybe some BGP?
So when I build core infrastructure equipment, it's pretty common for me to say at most there's the WAN, the LAN, and then maybe a management if there's multiple interfaces that face different parts of the network that allow me to get remote access. I use a ton of IP firewall address lists. I don't use very many interface lists personally.
Okay. So
I typically just use the WAN and the LAN. And I would say the right time to do it is when you do need to manage multiple interface settings on more than 2 interfaces.
okay, so you'd have 3 interfaces, and they're all going to be set for very similar, all of them identical settings. Put them on the same list at that point, but unless you're managing more than 2 interfaces, stick to the mangle method.
Well, so you should consider all of the firewall facilities as one mechanism. So all firewall filter, firewall NAT, firewall raw all have access to the interface list trigger. So it's not just mangle is what I'm getting at. I was just using mangle as an example
Okay.
of something that I might want to do on a group of interfaces versus just an individual.
So I'm back here on the firewall, and I'm pulling this up. That's the one that we created earlier, the jump. And you're talking about over here in advanced and IP options, you would then be able to select an interface list.
Not in IP options.
I mean
So
ICMP, sorry.
nope. So those are both
Okay.
back on the general screen. I can't, it depends on which firmware this is. Right there. Yep. So you've got down at the middle of the screen, little below the fold is in interface list, out interface list.
There they are. That's the same interface list right here. Okay. So right here on the general tab of your rule.
Yeah,
is a
so one
place-
thing that we could do, for example, ICMP is a good example. If you defined your WAN interface and your LAN or customer interfaces, right? We might want to say, hey, this core router, these 2 or 3 or 5 interfaces face upstream. This is the internet facing. I want to only allow ICMP echoes and ICMP replies. They can do that ping only, and that's the only thing I want to allow. But maybe on my internal network or my customer network, I'm going to allow them to do whatever kind of ICMP they want. They can get redirects, they can get additional information using ICMP protocol. And you could even have, 3 different rules here: one for WAN, one for customers that are not trusted, and one for infrastructure. And that would be a reasonable way to use the interface list, in my mind.
Okay, it's making more sense now how the interface list gets applied into the firewall section. It's basically all of your firewall sections have access to the interface list, like what you said earlier. And then if you choose to or don't choose to use that mechanism, the firewall sections will all still work independently from the interface list.
Yeah, it's just about options, right? So in that case, right, if I had 5 WAN connections that this guy had separate physical ports, physical interfaces facing, if I'm doing this without an interface list, I got to build 5 firewall rules.
So that's like an SD-WAN scenario.
Could be, yep.
Okay.
All right, so looking at a couple more rules here. We've got this VLAN, VLAN, VLAN. And I think if you make that guy bigger again, I think we were seeing 0 counters on those guys because he's...
There we go.
Yep. So the next guy with counters is our allow internal nets out. So we've got except on the input chain that's not WAN. And the source address list is internal. So if we double click on this, we can learn some more info about this. And it looks like we've got a fair amount of traffic on this. So the exclamation point there means not WAN. So if we look back at our interface lists, we can get an idea of which interfaces this is going to apply to. So on the top left, let's click on interfaces. And all right, so interface list. So this is going to apply to Ether 8, 7, 6, 5, 4, 3, 2.
The bridge.
Yeah, so it's basically applying to everything except for Ether 1 and Bridge WAN.
Okay.
And then it's got a source address list of internal. So now we have to go to the IP firewall and click on the address list tab at the top to see what internal means. And so what you can do,
Right.
rather than look through all of this and kind of find it, nope, just stay on your IP firewall address lists. And then at the top right, you can either search or sort. So click on the all button and switch that to internal. All right, and so this is a similar deal. Again, we can, just like interface lists, we can have an address list. This is gonna allow me to say, hey, for these subnets, prefixes, IP addresses, I want to bundle them together for single firewall rules or firewall facilities. So in this case, this looks like RFC 1918. It's 10.0, 172.16, and 192.168. all of those addresses are allowed. So back on our filter that we're looking at, this guy is saying when it's just like I talked about earlier, this is basically following that strategy that says, hey, if you're coming from a private IP and you're on not the WAN, we're going to allow that traffic to talk to this router.
To go out.
Just to talk to this router. It's an input.
Because
Yep.
it's an input. That's why.
Yep. Now, what might be interesting, this does mean that if you NAT to your customers, and your customers get private IPs, it's possible that your customers could be trying to brute force your MikroTik and see what they can do. So one of the things that I like to do that maybe we can cover on the next one is kind of investigate that traffic. And you could do that two ways. One, you could do a packet capture and kind of look at things. But packet captures, the closer you get to the core of your network, the more traffic will be there and the more difficult it will be to sift through the deluge of volume of traffic. So one of the things you could do right here is, well, I don't know if it makes sense. We're talking about it, we might as well do it. So we'll take note here that this is input internal, not WAN. And let's look at any other triggers here. Go to advanced and extra. No other triggers there, no other triggers there. And then action is to accept, I think. So what we'll do to be lightweight on the MikroTik is that we'll go ahead and hit cancel here. Let's go to raw, because from left to right, well, except for layer 7 protocols, which is very heavy, traffic is handled more lightly on CPU and resources by raw than it is for mangle, and mangle than it is for NAT, NAT than it is for filter. Layer 7 protocols is the heaviest weight, most resource intensive. So the reason I'm going to build a raw rule is because it's lightest on, and it happens earliest in the packet flow. And so if you haven't ever looked at this and you really want to get geeky, nerdy, network engineering, then one of the things that you can take a look at is do a Google search for MikroTik packet flow. And there's some nice diagrams in there for how packets run through the router and what processes they go through. We're not going to go into that right now, but if you click the plus here, we're going to build this rule that's going to tell us something. So now there's different chains than what you had for firewall filtering. In this case, we can either do pre-routing, post-routing, or input, output, forward. We're going to do pre-routing. It means it happened. We're going to trigger on this right away as soon as this packet gets into the routing engine. And then source address list is going to be our internal, not source address, but source address list.
There we go.
So we're going to basically match the same criteria as the filter rule does. And then in interface list is going to, in interface list is going to be not WAN. And you do the not by clicking the exclamation there. Yep. So now when it's not coming from the internet and it's internal with a private RFC 1918 IP, now we're going to pick an action at the top tab. What do we want to do when we match this packet? We want to add the source address to an address list. So we want to find out who's trying to talk to this MikroTik. I want to know. So this address list is going to be any arbitrary name. So we pick a name and we put it here. So in this case, I'm going to say, let's call this
Who is it?
attempted access.
Do I need to do any dashes or no
It
spaces?
doesn't matter, however you want to put it.
Sometimes.
All right. Look at that. We've already matched 12,000 packets. So let's look at address lists now and switch our filter from internal to attempted access. Holy moly. That's a lot of stuff talking to this router. So these guys could be doing anything, right? We haven't defined the criteria any further than this. So they could be doing SNMP, they could be doing ICMP, they could be pinging, they could be attempting to talk OSPF. They could be just broadcasting out there and trying to discover this router as a neighbor. We didn't define what type of traffic it is. We just said who talks to this router at all. Hopefully some of these IPs mean something to you. And any ones that don't, maybe we want to start investigating on, well, why is this one talking to this router?
Okay, so I'm going to sort by address just so I can kind of go through here. These first ones, the 10.0.0.100 somethings, those are base station routers. They're just simply Power Box Pros, OmniTics, and they all have PoE out so that we can stick point to point and point to multi-point antennas for OSPF distribution and point to multi-point to the subscribers. So the top section here are the main routers on the network.
So let's do this real quick, because this will maybe rule out a whole bunch of things. If there's a routing policy that really segments and isolates the network very, very heavily, then we shouldn't see a whole bunch of IPs here. But if we have more of a little bit of a flatter network, then we probably will see more of the IPs here. So let's go to IP addresses and see if we are the router for any of these guys. Because if we are, then we're probably going to see a fair amount of that traffic. So it looks like the 10.1 network has some interfaces here.
And that's this router.
Yep.
Yeah, okay, sorry. Go ahead.
Yeah, and that's a loop back, so that's a /32. What I was getting at is that we were seeing some, if you see the 10.1.100, 10.1.101, I expect to see a fair amount of those guys just pop in here, just because even raw network discovery is going to pop them in here because they're just ARPing for their gateway. You're going to see that pop into here because that's going to create traffic that triggers on the rule that we specified. So it looks like, a little bit of interrogation might be warranted here to find out what some of these IPs are and why they're communicating with this MikroTik. What we can see there is that there's not a whole lot of explanation for why so many devices are communicating, just by default with this MikroTik. One of the things that I had thought of as a possibility was that if we're on the same broadcast network with a bunch of these guys, then it would make sense that many of them are talking to us. And, if we were the default gateway, for example, for subnets that are part of VLANs that each of these represents, then we totally would see all of these pop in here.
Let me just pull up one of those that's of question real quick. Do you have one that you think is more important, like 10.1.100.1?
Yeah, I don't know if we should spend any, we're down to a couple of minutes of time here available. So I don't know how much we want to dive into that specific thing, or if we want to kind of take a look there and see if there's any more firewall rules that we want to dive into quickly before we.
Okay. Yeah, check out one or two more of whatever you'll allow.
Yeah, so internal net's out. You can see there, I'm guessing that also source address list of internal. Now it's going out the WAN, and we're allowing this traffic. Typically, output traffic is always allowed. So if you hit cancel here, I wonder if this was just somebody trying to debug and troubleshoot and see if any traffic was going there. If you sort by chain. Yep. And now let's scroll down and look at the output chain. I would guess that output traffic. So again, MikroTik by default always allows traffic. So you can see here, this is the only output rule. So what it does in the routing engine here, if you look at the packet flow diagram, it goes, hey, this packet was started from this router and is going out the WAN. And then does it match this firewall rule? And whether it does or not, the next step is to do nothing with it, allow the traffic, because there's no drop rule. So because the default action on a MikroTik is to allow the traffic, you have this one counter traffic or when I say counter, I mean that it's just counting the packets. So that rule 27 there is just literally asking, are we sending any private IP sourced traffic out the WAN? And it looks like it's just there to track number of packets that we send.
So here's the source address list that says it's inside, and
Yep.
the chain is output. So that means that when it hits this router, it's supposed to go further on instead of just stay there.
Nope.
No. Okay.
So to be more clear about that, input means that some other device wants to talk to this MikroTik, not through this MikroTik, not to some other device, to this MikroTik only. That's input. Output is the opposite. That means this MikroTik wants to talk to somebody else.
Okay.
So that means it's always has to be sourced as this MikroTik if it's on output chain, and then forward means it's passing through.
Okay. I'm a little bit confused why an output and a forward, like if you have network traffic on your private network is trying to egress out to the internet across this router, then the chain is output, the source address list is internal, and the out interface list is WAN. But why wouldn't you forward it from this router to the internet? Why is it output instead of forward?
So what I'm trying to point out is this firewall rule is doing nothing except for counting packets.
Okay. Okay.
Now, in a similar way, if we wanted to understand why there's packets here at all, we could build another raw rule or a manga rule, and we could add source to address list by using the same triggers here. What I would guess is that this happens when this router generates some type of traffic that goes out the WAN, which could be like maybe when OSPF drops and we're trying to find another path out. Maybe we source a packet from our loopback address or something like that. You wouldn't know without investigating a bit deeper into the configuration. You can see here there's 2211 packets since reboot, and that number hasn't increased since we've been looking at it. So it doesn't this rule doesn't trigger often.
Okay.
But realistically, I can understand somebody maybe wanted to know why this router ever sends private IP traffic out towards the internet, because it really shouldn't.
Okay. So it's set up as a counter just so it can be it's an observational tool.
That is what I would put into the comment, because the comment that is there now implies that this is needed for customer traffic, but it's not, right? This is not allow internal nets out. This is really observe private IP going to internet.
Internal nets out, which essentially.
Yeah, and I don't love those words. I would call private IPs, because internal again could mean your infrastructure, or that could mean the private IPs, or that could mean customers. And in this case, the internal list represents RFC 1918 private IPs.
Okay.
And so that's our only output rule. So again, this is just a counter. It's not doing anything. If we had an output rule that also blocked other types of traffic, then this rule would be our exception that's allowing traffic before the drop. But because there's no drop rule, nothing gets dropped. Everything is allowed.
A total beginner question here. When you mark a packet, that's what we're doing right here, or is that something else entirely together?
something else entirely altogether. So
Okay.
marking packets is something you do with the Mangle facility, and packet marks are something that you can use as a trigger. So commonly what you'll do is mangle a packet, and that means define a criteria that a packet matches on. And then when you match that type of packet, you want to do something with it. And that something could be apply a quality of service. It could be, rate limited or shape it in some way. It could be set priority on it, or it could be, do a type of filtering or even routing and say, hey, I want to do some policy-based routing. So this type of traffic uses my high-speed internet with low latency, and this other type of traffic uses my low-speed internet with just tons of capacity that I buy in bulk, but it, has higher latency.
Okay, yeah, this is so complicated that my ability to absorb everything is well, it just takes a while.
There's a lot to it here.
Um,
So we've gotten through about half of the items here. I think we've got more stuff that we could take a look at.
okay, I've got it resorted, and I think we were back
I
up
think
here. Do you want me to go back to sort by chain?
No, you can sort by number, but I think I'll kind of wrap up here unless you've got any questions that you've got burning for you that you want to get tackled today.
Well, the interface list issue was something that's been a nagging question. It's and how it applies, how it's applicable in other areas such as the firewall. That was really important to clarify because I didn't really piece it all together for where this is applicable. I thought well, this is just for myself. It doesn't matter what I name it, but over here in the firewall area, it does matter.
You got it. Yep. And it's just a mechanism to help you out. But yeah, it does matter.
Would you say it's
It's
like
a
a way to
relatively new
catalog?
thing. As a person who's been using MikroTik since 2000s, this is something that didn't always exist. So
Yeah, version 6 and all the versions since back then, it's a lot of changes. I get it.
mhm. So
Um,
there's many times where I forget to use that because it wasn't always available.
oh, okay. So right now, the way we've been using it is to just on our OSPF side on the backhaul side of our network, we've been using the interface list just to identify whether this point, like if it's a point to point for two radios, and then that's a /29 network. So we've got 8 total IPs, and 5 of them are usable. So we're using the .1 and the .6 for our gateways. We're using a .2 and a .5 for point to point. So we put a bridge interface on the point to point, put both the ether and the WLAN on that bridge. We give that bridge an IP address and assign it to the address to the interface list of external, and then it becomes a part of that whole subnet. Everything's labeled interface list external, and we know that any of those /29s are all backhaul and external.
Okay. And that's a reasonable way to do it. Yeah, so there's more than one way to skin the cat, so to speak. So you could use an interface list because you're tying everything to bridges. You could also use the bridge to identify how you want to apply firewall facilities. And further than that, if all of your backhauls slash externals come from the same subnet scheme, for example, maybe you use 10.100.101 at this site, then it's 101 with the first /29, and then 101 with the second /29, and then 101 with the third /29. You could also just say 10.100.101 /24 gets this policy. And so there's many ways that you can accomplish the goal of what you're trying to do. And interface list is one possibility. Address list is another possibility, and there's still nothing wrong with having individual firewall rules. One of the benefits of having individual firewall rules is you can tell which ones are matching the traffic. Whereas when you bundle them together like this, you don't know, for example, well, hey, if I tied all these interfaces to external, is that traffic coming from Ether 5 or Ether 6? Without having individual firewall rules, you can't tell that from the counters.
Gotcha. So I guess one of the things that we would really like to do now, we're a small company. We have 3 different fiber connections. We're working on our 4th at different geographies with small amounts of subscribers behind each fiber connection. It's not nothing to brag about as far as numbers go, but what I definitely want to be able to do is make sure that we've got all these people on a solid setup. I've had a total of 3 different engineers working, not counting you. I've had 3 different engineers working on this network at different points in time. And so at some point, I need to actually just go through and clean out what's old and not needed, switch strategies from identifying bad guys to just blocking all external forces that aren't, if somebody doesn't make a call to an external source, they don't need to be getting in. This the firewall.
I like that strategy, because looking at your firewall rules that are still remaining that we haven't talked through yet, you can see here that basically rules 30 through who knows how many, it looks like 50, 60, 70. A bunch of these are add to the bad guy list. If you take your action, you can see there it's add source to address list, and all of these are going to be, hey, I'm finding out the good guys and I'm finding the bad guys. I'm finding the good guys and I'm finding the bad guys. I don't like to track those dynamically. I like to say, here's the good guys. There's only 6 of them. Oh, you're not a good guy? Well, then don't try to talk to me at all. Period.
Yeah, it's like walking down the street. You get people, don't talk to me. Don't talk to me. Don't talk to me.
All right, well, Jonathan, I've got to get going.
Thanks so much, Mark. We appreciate it.
Sounds good. I'm going to wrap up the recording here. So, hey, everybody, thanks for joining us. We will have another session where we'll continue this topic and we'll make another video. So hopefully you learned something today and hopefully you learn something in the future. Are you a network engineer or operator with questions, ideas, and stories to share and want to connect with us on Bridge Mode? Send us an email at bridgemode@admiralplatform.com to get the conversation started.